Hello grade 11s and welcome to the very last problem in the set of videos on the paper 1 exam. Again, this is not from a specific question paper but has been put together by using a whole lot of questions from past papers. So question number 6 is again a question on electric circuits, but here we're taking a look at ohmic and non-ohmic conductors. Specifically, we're looking at an investigation. With question 6.1 reading as follows. It says, students carried out an investigation to determine whether or not conductor Z is ohmic. They set up a circuit as shown in the diagram below. The internal resistance of the battery was negligible. So in the circuit, we see a battery, we see a voltmeter, an ammeter, resistor Z, and a rheostat. Remember, another term that we use when referring to a rheostat is a variable resistor, because it is a resistor whose resistance we can change. And when we change the resistance of this resistor, we change the total resistance in the circuit, and that will affect the amount of current that is flowing through the circuit and the amount of potential difference that we're going to measure across resistor Z. So now the question continues and they say, define the term ohmic conductor. So if you take a look in your exam guidelines, you're going to see that there is actually not a definition for an ohmic conductor, and that is why this question is only out of 1 mark. We say that an ohmic conductor is a conductor that obeys Ohm's law, and for writing this down, you're going to obtain 1 mark. I just noticed that there's a mistake with the numbering in this question. This should be question 6.1.1 and this 6.1.2. So I'm going to change that. Question 6.1.2 says, identify and write down one error made by the students when connecting the circuit shown in the diagram. This should be an easy question for you in grade 11. We know that ammeters are connected in series because current flows through the ammeter in order for it to detect the rate of flow of charge, or the rate at which the charges are moving through the circuit. But a voltmeter measures potential difference, and it should therefore be connected in parallel. If you connect a voltmeter in series, often you're going to find that the current is negligible or extremely low because a voltmeter has an extremely high resistance. So the mistake that was made is that the voltmeter was connected in series, when it should be connected in parallel. For writing down that the mistake is that the voltmeter is connected in series, you're going to obtain 1 mark. So now we can move on to question 6.2. It says the students corrected the error mentioned in question 6.1.2 and then collected the following ammeter and voltmeter readings during the investigation. So we have a whole lot of readings and then we go on to 6.2.1. It says, given that the current is the independent variable, plot a graph of potential difference versus current on the graph paper provided. Draw a line which best fits all the plotted points. Now, unfortunately, the memo for this question is not available, and based on that, I had to plot a graph using Microsoft Excel. And this graph, of course, does not make use of a line of best fit, but rather a curve of best fit, which is actually better for the set of data. So in this case, you're going to get 1 mark for plotting your points correctly, 1 mark for using a curve of best fit instead of your ruler, 1 mark for your labels. The current should be on the x-axis because it is the independent variable. Remember the stick and the stone. The stick is going to fall down onto the x-axis when the wind blows. The potential difference should be on the y-axis. So for drawing or writing down current in amperes and potential difference in volts, on the correct set of axes, give yourself 1 mark. And for using a suitable scale for each axis, give yourself the 4th mark. So you will see that I measured or counted in 1, 2, 3. So in whole numbers. On the x-axis and on the y-axis, I used a scale of 0, 2. So 0, 0, 2, 0, 4, etc. You need to use a uniform scale, please. So in other words, you can't go 0, 2, 0, 3, 0, 5, 0, 7, 5. You need to use a uniform scale. And that gives you 4 marks. Now question 6.2.2 says, write down the name of the physical quantity represented by the gradient of the graph. So in this case, we only have a straight line over here, not the entire line is straight. But if we would like to calculate gradient, remember gradient in physics or physical science is not given the symbol m. Instead, we say grad for gradient is equal to change in the y values divided by change in the x values. In this case, the y values are the potential difference and the x values is the current. We know V divided by I is equal to R, the resistance. So the name of the physical quantity represented by the gradient is the resistance. And for writing this down, you're going to obtain 1 mark. Now we have the last question, and this question says, is conductor Z an ohmic conductor for all currents in this investigation? Give a reason for your answer. The correct answer is no. And the reason is because of this section over here. So we can say that for currents greater than 0,8, we find that the potential difference is no longer directly proportional to the current. Yes, it is true that the potential difference does still increase, but we don't have a linear relationship, and therefore the answer to this question is no. You're going to get 1 mark for your answer no, and 1 mark for your reason. So grade 11s, this brings us to the end of the set of questions on your paper 1 exam. Thank you so much for joining me. I wish you all the best for your November exams and for grade 12.